All right, so on this one, I'm going to have to get out of the big screen here. And because I'm going to have to move this here line around. I made a line. I'm going to move it around to kind of line up where the percents are and see where we are as we go across and read things. So it says the survival rates of 3 stages in the development of a flower beetle, egg, pupa, and larvae, are as a function of the relative humidity shown below. We're supposed to fill in each of the following blanks with the appropriate stage, egg, pupae, or larva. And so basically it says at 60% relative humidity, so I'm going to move this over to 60%, so about right there. The rate of change of the survival rate of blank and blank is positive. So we want to have a positive number. And so that means we're going to have to go up. Well, looks like this one is going up, which is eggs. Pupa looks like it's going down the whole way, and larva looks to be going up. So what I'm going to say is it looks like the eggs, I'm just going to put E, and the larvae. Okay, so look, wait, larvae is going down. Yep, positive. Pupae is going down. Okay, eggs and larvae are the ones we want. All right, so now an increase in relative humidity above 60% improves the survival rate of what and reduces the survival rate of what. So basically, as we come further to the right, what happens? Well, if we come further this way, we're increasing the survival rate, which is the number over here, of the larvae, as well as the eggs up to a certain point. Okay, so the eggs and larvae both look like they go up. So we'll write eggs and larvae here and reduces the survival rate. Well, this one keeps going down the further we go this way. And so the pupae are going to be here. All right, so the next one says at 97%. So let's go up to around 97%. So get rid of pen. So we're going to be somewhere maybe in that range here. Who knows? The tangent to the blank survival curve has more negative slope than a tangent to the blank survival curve. Okay, well, we're not even worried about larvae because it stops right there and then it's done. So we're trying to decide which one is going to be steeper at this point here. Well, it looks like the one that comes down at a steeper rate, which looks to be the blue one, which is eggs, is going to be the one it's going to be more negative. So the tangent to the egg survival has more negative slope than a tangent to the other one is pupae. Okay. All right. Now, any tangent lines drawn on the survival curve for blank will have a negative slope. Well, that's the P because we said it's always negative. No matter where we are on there, it's always going to be negative. Now, the slope for the survival curve for blank is always positive. Well, the one that's always positive has to be the larvae. Okay. Now we're going to 30%. So let's go up here and get rid of our pin. And we'll go over here and put this around 30%. So maybe about there. And the slopes of which two are nearly equal? Well, the only two that are going the same direction are the blue one and the black dotted one. So it's going to be eggs and pupae. Okay. And if you think about it, they're both kind of tangent here, so they look to be about the same. All right, so now back to 65%. So if we go over here and get rid of our pin again, and we move this over to 65, that would be 70, so somewhere maybe in that area there. The survival rates for blank and blank have approximately the same slope. All right, well, again, this is going to be a negative slope. The other two are positive, so that means it has to be larvae and eggs. So we have larvae and eggs, okay? And again, sometimes your curves aren't going to be so nice. It's going to be pretty close, and then you have to think about, okay, tangent. Maybe it's tangent to this, so it would be some line like that, and then you have to think about what is this one? Well, this one is tangent like that. This one is tangent again like that. And so none of those have the same slope. So if they were asking about, whatever that value is at that point, about 50 something maybe, then we'd say, there's none of them are equal. So some cases are going to be easier than others, and some are going to be harder than others. All right, so what do we have here? So it says a tangent line drawn at label point. So we have this point here, and that's going to be the thing. And we're supposed to estimate a second point on the tangent line. So, we can move this around anywhere. We can say, okay, well, what about if we wanted it at 4? Where is this going to be? And that's why I'm saying I have to use the up and down, or the smaller screen, because I have to be able to move these things around, because I cannot draw straight lines here. And so where would we call that? I don't know. That's maybe there. Who knows? All right. And so we would have 4. Let's go ahead and put our inking back on. And so it looks like it's going to be at 4 comma, and well, that's going to be 93 about there. That looks like halfway, so maybe 92.50, maybe. I don't know. That looks like my best guess anyway. And so that's going to be the estimate the second point. That's where I'm saying my second point is. All right, so now it says calculate the rate of change of the function at the label point. Report the change with units of measure. Okay, so we want the rate of change. Now that's, remember, that's going to be our f prime of x. And so that's going to be, if we use these 2 points, it's going to be 9400 minus 9250 divided by, and now we have 4.8 minus 4. And so that equals, plugging that into my calculator, we have 9400 minus 9250 divided by 0.8, and we get 187.5. So 187.5. And now what is that? That's 1,000 employees per, and it's going to be per year. Okay. And that would be our value. Now, I used f prime of x, but it looks like it's going to be p prime of t. But anyway, that's neither here nor there. So we're using f primes, and we're switching it. So we're saying that's f of x, and this is x. So we've kind of changed the problem a little bit, but that's okay. Now we're supposed to calculate the percentage rate of change of the function at the labeled point. Report the percent rate of change with units of measure. Okay, so we're doing a percent rate of change. So percent change, I'll just say, just for simplicity. And so now we're taking the f prime of x, the 187.5, dividing it by our value at the point of tangency, which is 9400. And then we have to, of course, multiply by 100%. And so we have that number divided by 9400 times 100. And it looks like we get 1.995%. Okay. And that's percent what? Per year. Okay. And that's because we have, this was thousands of people per year, and so we still have that per year there, and it's just going to be percent, because the people divided by people is going to be gone, and we just have per year times and then percent on top, so it's the percent per year. Okay. Now, is there anything else? I think that's all we need. So that's how we would do that one. Again, we have to use our formula for f prime of x, and then our percent change, which uses the f prime divided by the output for that point on the tangency. Now, if we'd had a different point of tangency, then we'd have to use a different value for that output. All right, so let's stop there.